Hello Godotneers! When you start out with Godot, you often build all your game logic with Godot's nodes. And this works for a while, but when you add more and more features, it often becomes difficult to make these features play with each other. Often the same objects need to be used in different situations. For example, a weapon in your game may appear in the game world, but should also be used in an inventory dialog. Modeling all of this with nodes only can become really difficult over time. So in this video, we are going to explore how you can use data models to represent items in your game and how this greatly simplifies the development process. We are also going to explore how you can extend and combine these data models to add new features to your game. Finally, we are going to look at some tools that can help you with maintaining your data models so that you can easily tweak and balance your game based on player feedback. This is an intermediate level tutorial. To make the most out of it, you should have a basic understanding of GDScript and Godot's node and scene system. It will also help if you are familiar with Godot's user interface system, because we will build a few dialogues throughout this tutorial. So we start with this little game. And this could be some kind of RPG or crafting game where the player can move around and pick up stuff and craft new items. Here we have our player, and we call him Mr. G. And Mr. G can only move around and collide with stuff, and that is about everything Mr. G can do. Now we want to implement a new feature where Mr. G can pick up stuff from the ground. Before we can teach Mr. G how to pick up stuff, we need to have something that Mr. G can actually pick up. So I have prepared this little pickaxe here. Now, how would we implement picking up an item? Well, the first thing we need to do is to be able to see the thing that we want to pick up. So we need to put this little pickaxe into our world. And now when Mr. G walks over this pickaxe, he should automatically collect it from the ground and put it into his inventory. We're going to do the inventory part later and start with the collect from the ground part. For this, we need to detect when Mr. G walks over the pickaxe. And we can use an area 3D for this. So let's add a new node 3D. So we have a root node that keeps everything together. And then we put our pickaxe below this node 3D. We also add an area 3D so we can detect something. So Control A to add a node, area 3D, and there it is. So this area 3D will detect our player, and we need to add a collision shape to it so the physics engine knows how big the area is. Over here in the inspector, we can pick a shape, and let's use a capsule shape for this one. Okay, that looks nice. So now when Mr. G walks into this area, the area will fire an on-body entered signal. And we can react to the signal and then tell Mr. G to pick up the pickaxe. So we create a new script and add this to our root node 3D here. And we name this pickup.gd. And now we can connect the on-body entered signal of this area 3D to this new script. So we select the area, and then we go to signals, and then we connect this on-body entered signal to our code. So now when Mr. G enters this area, then the area will call this new function on area 3D body entered. Okay, for starters, let's just print out something so we can see that it has worked. We can try it out. So we move around and we walk over the pickaxe and it works. Nice. Now we're able to detect that we have walked over this pickaxe. But what do we give to Mr. G when he walks over this pickaxe? We surely do not want to give Mr. G this whole 3D scene here because it contains a lot of stuff that we do not really need in an inventory. We don't need this area, we don't need this 3D model, and we also don't need this whole scripting around picking up items. So it seems that we need some kind of object that represents a pickaxe, but isn't directly shown in the world. And this kind of object is often called a data model. It is just a simple object that stores information about an item, but it is not concerned with how the item is shown or how it is used in the game. So let's create a data model then. A very simple way to do this is to just have a dictionary that holds all the information about the items in our game. So let's create a new script, and we call this items.gd. This script is going to be our items database. Now we're going to delete all of this, and we can give it a class name so we can use it in other scripts. So let's call it items. Now we create a dictionary, which we call database, and this dictionary is going to be our data model. So let's add an item to the dictionary. The first item would be our pickaxe, and we need to give this item an identifier or ID, so we can later refer to that item. Now we want to store a bit of information that describes our pickaxe, and for this we can just put a dictionary inside of our dictionary. And now let's think about which data would be interesting here. Well, the first really obvious thing is that we need a name for the thing. So let's add this information. And the name of this item is going to be pickaxe. So this should be enough information for now. We can go back to our pickup code and try to give this item to Mr. G. So how does Mr. G actually pick up the item? Well, currently only the pickup knows that Mr. G has entered its area. So it somehow needs to tell Mr. G, hey, there's a new item for you. Would you please pick this up? And we can implement this by defining a contract for the pickup. And the contract could be, if you want to be able to pick up items, well, you need an onItemPickedUp method. So in our code for the pickup, we can just check if the body that has just entered this area, in our case Mr. G, has an onItemPickedUp method. And if this is the case, well, then we call this method and we give it the ID of the pickaxe as a parameter. So Mr. G knows what he has picked up. And this is the ID that we have specified in our items database. Okay, so now we need to add an onItemPickedUp method to Mr. G's code. So we open the player.gd file, and then we add a new method here, onItemPickedUp. And this method takes a string as a parameter, which is the ID of the item. Mr. G currently does not have an inventory, so we are just going to print out the name of the item that we picked up, so we can see that it worked. Print I got A, and then we can access our items database, and we use the ID that we have received as a parameter up here to find the matching item in our items database. So items, database, and then we give the item as a key. And now we can get its name by just typing .name. Okay, let's try this out. We walk over the pickaxe, and we can see down here, it nicely prints, I got a pickaxe. Okay, great. So now let's also make the pickup disappear when Mr. G walks over it. So we go back to our pickup code. And after we have informed Mr. G that he has now picked up a shiny new pickaxe, well, we can just queue free the whole pickup and then it will disappear. Also, right now, this code only works for pickaxes, so maybe make this item configurable. Let's go up here, and we add a new export variable for our item ID. This is going to be a string, and now we can go to the inspector and type pickaxe into our new item ID field, right? And now we have a configurable pickup. And then we can use this item ID down here in our script where we give it to Mr. G. So we change this onItemPickedUp, and instead of the hard-coded string, we put in the item ID. Okay, this is great, but in our 3D world, we still show the pickaxe no matter which item ID we have configured here in the inspector. And it would be really nice if our pickup would automatically show a 3D representation of the item that we have configured here in our inspector. So how do we tell our pickup which 3D scene it should show? We could make another export, but then we would need to configure two things, and it's very easy to mess this up. So a better way would be to add the 3D scene as some information to our items database. So let's go back to items GD. And here we add a new property to our pickaxe, which we call scene. And then we can just drag in the pickaxe scene, and Godot will automatically create a string with the path to the scene. So now we can go back to our pickup code and use this information. We add a ready method. And in there, we first load the 3D scene from our item database. And we can do this very similar to how we got the name of the item. So var scene is load. And then we go items, database. We give it this item ID from our export. And then we load the scene. And now we have the scene in our hands, and we can create an instance from this. So scene instantiate. And then we can add this instance as a child of the pickup node. Okay, great. So we can kill this pickaxe model from our scene because it's now automatically created in our ready method. And let's see if that works. And yep, our pickup shows a nice 3D model of the pickaxe. Great. So maybe let's try to add a second item to our item database so we can see if this also works if we use a different item. We go back to our items GG script and we add a new entry here. And we give it the ID sword. And of course, it has the name sword. And we also add a reference to the sword scene. So we drag in the sword scene. Okay, so we can now go back to our main scene and let's reconfigure our pickup so it shows the sword instead of the pickaxe. And then we can run the game. Okay, something is not working. It looks like we have a typo here in our item ID. Well, this is not great. It would be better if there was no way to mistype this, but yeah, for now, let's just correct the typo and see if that works. So we restart the game, and now we can see that our pickup shows a nice sword instead of a pickaxe. And if we walk over the sword, we can see that now Mr. G prints out that he has picked up a sword. So you can see that representing items as a data model is really powerful because we can now easily add new items to our database, and all the game systems will be able to just use our new item immediately. So our pickup will be able to show these items in the 3D world, and our player will be able to pick them up. But our approach also has some drawbacks. Well, first off, we have the obvious drawback that it is very easy to introduce a typo here. We have just seen this when we configured the sword, but it's also easy to make typos in our item database itself because there's a lot of strings in there. A second problem is that we have hard-coded the paths to our 3D scenes into our items database. And if we now move a scene to some new place, or maybe we decide to rename it, well, then our items database will just silently break. Finally, if we think about it, this dictionary will be really hard to maintain once we add a few hundred items to it. So we would need to have a better way to structure our data that fixes all of these problems. Godot has a built-in feature for modeling all kinds of static data, resources. Everything that is static data in Godot is a resource. For example, scenes, textures, 3D meshes, audio samples, animations, they are all resources. Godot also allows us to create custom resources so we can model data that is interesting for our game. So let's create a new resource type for an item. We create a new script and we name it item.gd, and then we're going to delete all of this. Now we give our new script class a class name, and we name it item. And then we let the script extend the resource class. So now Godot knows that this is a custom resource. Just like nodes, resources can export variables that we can edit in the inspector. So let's add a few variables for our item. We already know that we're going to need a name and the scene that we want to use as a 3D representation for the pickup. So let's add an export for the name, export var name, and this is a string. And the second export for the scene. And for the scene, we are going to use the packed scene type instead of a string. And using the packed scene has a few advantages, which we'll see in a minute. Let's save this, and then we can create a new resource in the editor. So we right-click, new resource, and now we can search for item. And we can see that there is a new entry in this tree, which represents the new item resource that we have just created. So let's select this item and then click create, and then we can give it a name. Because we want to create an item for the pickaxe, well, we name it pickaxe.tres. And now we can edit this resource in the inspector. Here we can give it a name, pickaxe, and we can select the 3D scene that should represent this pickaxe in our world. And because we made this field a packed scene, we can now use this quick load option here to quickly select our pickaxe scene. Also, Godot will automatically fix the scene path if we move around the scene or if we rename it. Now we have a resource that represents a pickaxe, but how do we use this resource in our pickup? Well, let's go back to our pickup script. And instead of using a string here with the item ID, we can now refer to our item directly. So we change the name to just item, and the type goes from string to item. We also need to change the rest of our code so it works with our new item resource. So first we go to our ready function, and we do no longer need to load the scene here anymore because the scene is already part of our item. So we can delete this line, which loads the scene. And here in the second line, we can just use the scene from the item and call instantiate on the scene. And down here, where we talk with Mr. G, we modify our contract so that our onItemPickedUp function now takes an item instead of a string. And if we now go back to the inspector, we can use the quick load option to select the pickaxe resource that we have just created. And this is a lot easier, and there's no way to introduce a typo. We also need to update our player script. So let's move over there and find the onItemPickedUp method. And now this parameter here is not a string anymore, but it is an item. And instead of accessing our item through the item database, well, we can just use the name directly from the item that we have been given as a parameter. And this also means that we no longer need our items database, so we can delete this whole script. Okay, let's try out if everything still works. We start the game. And we can see that our pickaxe appears in our pickup. And if we walk over the pickaxe, we get our printout. So now we have a reusable pickup, and we can save this out as a separate scene. So we right-click the node, and then we select Export Branch as Scene, and we can name this pickup.tscn. And to keep things a bit organized, let's also create a folder named pickup, and then we drag the pickup script and the pickup scene into this new folder. So now it's very easy to add more items that Mr. G can pick up. So let's create a new item for a sword. And then we click create and name this sword.tres. And here in the inspector, we can give it a name, and we select the sword scene as a 3D representation of the sword in our world. Now we can duplicate the existing pickup and change its item from a pickaxe to a sword. And let's try if that works. We start the game. And Mr. G walks over the sword, and he also walks over the pickaxe, and we can see that he always picks up the correct item. This is nice, but it's not really terribly useful because we just print out the item and then forget about it. So let's give Mr. G an actual inventory and show the inventory contents to the player in some kind of inventory dialog. So let's start with the inventory. We create a new script, right-click, new script, and we name this inventory.gd. And then we're going to delete the contents, and we can start with our inventory. First, let's add a class name, inventory. And an inventory, well, it could be a node, but we really don't need any node functionality here. So we make it a simple object instead. So extends ref counted. And because ref counted is the default, we can just leave it out. So let's delete this line. Now we need a place where we store all the items that are in the inventory. So we're going to create a new array. So var content, this is an array of items. And we are going to initialize this with an empty array, so we don't need to do any kind of null checks. We also need a function to add an item to the inventory. And this takes an item as a parameter. And in here, we can just append this item to our content array. A function to remove an item from the inventory would also be nice. So let's add another function, remove item. This also takes an item. And in here, we just remove the first occurrence of this item here that we get from our content array. And finally, we add a function that just gives us the contents of the inventory, and we call this getItems. And this returns an array of item. And we just return this content array. Well, that is a very simple inventory. We don't have any stacks or slots, but for now, this is good enough. And now we can add this inventory to our player. So let's go back to our player script. And here we create a new variable, var inventory. And this is of type inventory. And we just make it a new inventory. Great, now our player has an inventory and we can use this in our pickup function. So let's go down there to on item picked up. And here we just add the item that we picked up to our inventory with the new add item function that we just wrote. Now it would be really nice if we could actually see what is inside of our inventory. So let's create a very simple inventory dialog. We make a new scene. And this is going to be a user interface scene. And we save this as inventory dialog.tscn. Let's rename the root node to inventory dialog. And we also change its type to be a panel container. Let's first add a little title bar and a close button so that we can close this dialog. So we create an hbox container to get a horizontal title bar. And inside of this hbox container, we add a label. Let's call this title label and a button for closing the dialog. And let's call this one close button. Now we can set up the label. So let's change its text to something like Mr. G's stuff. And we want to center this label. And the label should also take all horizontal space. So we go up here and we tick the align with expand checkbox. And then we horizontally expand the label to fill all the available space. If you don't know how container layouting works in Godot, I recommend that you have a look at my UI basics video. There's a link to that down in the description. Okay, so now let's configure the close button. We're just going to give this one a little X as a label. And our title bar is done. And next is the part that actually shows the inventory contents. A lot of games use some kind of grid to show inventory items, so let's do that as well. We add a grid container. And we want this grid container to be below our title bar. So let's add a VBox container. And now we can just drag the HBox container with the title bar and the grid container into our VBox container. And the VBox container will just stack them on top of each other. Now inside of this grid container, we want to show the inventory contents. So let's first add a panel container into the grid container. So we have some kind of background. And inside of this panel container, we put a texture rect, which is going to show an icon of the item that is in our inventory. Well, let's quickly load an icon here, maybe this sword icon. And that looks pretty nice. Now, if we duplicate this panel container a few times, we can see how this is going to look when we have a filled inventory. Our grid container only has one column, and that looks a bit odd. So let's increase the columns of the grid container to maybe 5. And that looks a lot more like an inventory dialog. Nice. But how would we show the actual contents of our player's inventory and not just a dummy like this? Well, we can do the same thing that we just did here in the editor, but we do it in code. So we walk over the inventory contents, and then for each inventory item, we create one copy of this panel container. And then we set the icon to some icon that matches the inventory item. And finally, we put our finished item slot into our grid container, and this way we can build up our inventory step by step. So first let's extract our item slot here into a separate scene so we can quickly make copies of it and we don't need to build and arrange the panel container and the texture rect in our code. So we right-click this node and then we select Save Branch as Scene and we name this itemslot.tscn. Okay, now let's clear our grid container and then we can start writing a script. So we add a script to this inventory dialog node and we name it inventory dialog.gd. And we're going to delete all of this. Let's give this a class name, inventory dialog. Okay, first let's make the close button work. So we select this button and then we go to the node's signals and then we can connect the press signal to a new function on close button pressed. And inside of this function, we just hide the dialog. The next thing we want to do is to fill this grid container. And for this, we need to have access to this grid container in our script. So let's right click it and then select access as unique name. And then we can control drag this grid container into our script and we get a nice onReady variable. So why did we do it with a unique name? Well, the reason for that is that unique names have the advantage that we can move our nodes around and we don't need to change our script all the time because this unique name is going to be the same no matter where in the tree this node is going to be. So if we decide to rearrange items in our UI a bit, well, we still don't break our script. Now we need a function that opens this dialog and shows the inventory contents. So let's make a new function and we call this function open. And because we don't want this dialog to be concerned with where the inventory is actually stored, we will just give the inventory as a parameter to this function. And then whatever code tries to open the inventory dialog needs to supply the inventory to our dialog. And this way we can keep the dialog independent of the rest of the game. So first we show the dialog, so we just call show. And now we can walk over the items in our inventory. So for item in inventory get items. And for each item, we want to create a new item slot inside of our grid container. We already made a scene for this item slot, but we don't want to hardcode the path to that item slot scene. So let's export this as a variable. Let's go up and we write an export var slot scene. And this is a packed scene. And here in the inspector, we can just drag the item slot scene into this new field. And this way, Godot will automatically fix the path to the scene in case we reorganize our project. Now we can go back to our loop, and here we can instantiate our slot scene. Now we can add this to our grid container. But we still just have an empty slot without an icon. But where do we get this icon from? Well, we can add it to our item description, just like the 3D scene that we have added before. So let's go to our item script. And there we can add an export variable for the icon. So export var icon, and this is a texture 2D. And now we can add an icon to the resources that we already created. For the pickaxe, we use this pickaxe icon here. And for the sword, well, we get the sword icon. Now we can go back to the inventory dialog and we can use the icon and put it into our item slot. But how do we get it in there? Well, let's have a look again at the item slot scene so we can see how it is built up. We have a panel container at the top and a texture rack directly below that. But this item slot really is its own component, so the inventory dialog should not know how this is built up internally. So maybe let's add a script to our item slot, and we're going to delete these two functions. And then we can add a new function that will actually show an item. Show is already taken as a name, so let's call this function display. And this function is taking the item that it should display as a parameter. Now we need to access this texture rack, and we already know scene unique names are the way to go. So right click, access as unique name, and then control drag this into our code. So now we have an onReady variable, which is of type texture rack. We can use this to show the icon of our item. So we write texture rack.texture, and this is item.icon. Great, now we can go to the inventory dialog and use this new function. So inside of our loop here, we first add the slot to our tree. And this is important because the onReady variables of our item slot are only initialized after it has been added to the tree. So we really need to add it to the tree first, and then we can call our display function. So slot display item. And that should do it. So let's add our inventory dialog to the game. Our game does not have any UI elements yet, so let's start by adding a canvas layer, and this canvas layer will contain our user interface. And we name this canvas layer UI root. Technically, we don't need a canvas layer in 3D games, but I still like to add it because this gives us a nice separation between the 3D part and the 2D stuff. Let's switch to 2D mode so we can actually see what we're doing. And now we can drag our inventory dialog into this canvas layer. And to keep our inventory dialog always centered, we go here to anchoring, and then we pick the center anchoring preset. And now Godot will make sure that this dialog is always centered, no matter which resolution or aspect ratio we have. Let's also hide the inventory dialog, so it only shows up when we press the inventory key. We're almost done, but we still need to add some code that actually opens this inventory dialog up. Now, where should we put this code? Our inventory is a component at the player. So we could open up the inventory dialog directly from the player. But then the player needs to know about our game's user interface, and I don't really like that. We want our components to know as little as possible about each other, and I think in this case it is probably better if we have a third component that brings our player and our inventory dialog together. So let's add a script to our UI root here, and we call this uiroot.gd. Now, our UI root script needs to know about the player and the inventory dialog. We already know how to do that, so we make them scene unique nodes. And then we can just control drag them into our script. Now we want to be able to press a key to open the inventory, so we need to create a key binding in the project settings. Let's go to Project, Project Settings. And up here, we select the Input Map tab. Now we can add a new action. Well, let's call this Inventory. And then we scroll down and we add a key binding to this action, which is I for Inventory. And now we can use this key binding in our script. Let's go back to our UI root script. And we add a new function, unhandled input. So this is called for all input that is not handled anywhere else. And in here we can check if the inventory key has just been released. So if event is action released inventory. And if this is the case, then we open the inventory dialog and show the inventory of the player. Okay, that was a lot of stuff. So let's try if this actually works. So we start the game. And then we pick up our pickaxe and we press I to show the inventory dialog. And great, our pickaxe has appeared in the inventory dialog. Unfortunately, we cannot click on our close button because our mouse is captured, because we're playing a 3D game. We would need to show our mouse when we open the dialog, and then we need to capture it again when we close the dialog. So let's add this to our inventory dialog script. So here, after we call show, we make the mouse visible. So we say input mouse mode is input mouse mode visible. And down here, where we hide our dialog, well, we just set the mouse mode back to captured. Okay, let's try this again. So we walk over the pickaxe. Now we press I. And our inventory dialog is showing, and our mouse is also showing, and we can actually click the close button. Awesome. So now let's pick up our sword, and then let's open up the inventory dialog again. And, well, we seem to have two pickaxes now in our inventory dialog. Why do we have a second pickaxe now? Well, let's look again in the open function of our inventory dialog. And we can see that whenever we call this function, we just add more and more items to our grid container. So when we open the dialog the first time, we add the pickaxe. And when we then picked up the sword and opened it a second time, well, we added the pickaxe and the sword again. So now we have two pickaxes and one sword. But well, this is easily fixable. We can just clear out our grid container before we add new contents. And then we shouldn't get any duplicate entries. So let's add a loop for child in grid container get children. And in this loop, we can just delete each child. So we call queue free for each child. Okay, let's try this again. We walk over the pickaxe and we open the inventory dialog. Pickaxe is there. We close the inventory dialog and we walk over the sword. And then we open the inventory dialog again. And this time everything renders correctly. This is nice. Let's quickly have a look at what we have built so far. We created a data model that represents our items. It holds the name, the 3D scene, and the icon of our item. We also built a second data model, our inventory. It just holds a list of items and provides a few useful functions to manage this list. but it isn't really concerned with how the items get in there or how they are rendered on screen. And because we have these data models, the rest of our game code becomes really simple. Adding an item to the inventory is one line of code in the player script. Showing the inventory items in a dialog is 4 lines of code in the inventory dialog. And because we can simply give the data model to any component, each component only needs to know about the data model, but is independent from other components. And this helps keeping our game manageable. And now let's see how we can use this data model to build additional systems on top of what we already have. And to do that, we're going to build a very simple crafting system. In general, a crafting system works like this. We have a recipe, and this recipe has some ingredients, and we get something produced from these ingredients. We currently don't have any kind of ingredients, so let's create a few more items that we can use as ingredients. Let's first create some iron ore. So we create a new resource, and we select item, and we call this one ironore.tres. And now we can give it a name, iron ore, and select an icon, and we can also select a 3D scene for that. And now we have an item that represents iron ore. Let's make a second item which represents an iron ingot. And this time we do it by duplicating the iron ore that we just created. So we select it and press Ctrl D to duplicate it, and we name it iron ingot.tres. We also change the name to iron ingot and pick a new icon. And we also pick a different 3D scene. Great. Now we have a few items that can represent ingredients for our recipes, and we can continue with making a data model for our recipe. So let's create a new script, and we call this one recipe.gd. And we're going to delete all of this. So let's first give this class a name. We call it recipe. And like our item, this is a resource. And now we need to think about what kind of data are we going to need in our recipe. Well, we'll probably need some title or name that describes what this recipe is going to produce. So we give it a name, and this is a string. And we will also need a list of ingredients that go into the recipe. So let's add a variable for that as well. This is an array of items. And finally, we need to have a list of stuff that is produced by this recipe. And this is very similar to the ingredients. It's just an array of items. So let's just copy this line and rename it to, let's say, results. Now we can create recipes. So let's create a new folder that we call recipes. And inside of this folder, we create a few recipes. So let's first make a recipe for an iron ingot. We give this a name. Let's call it iron ingot.tres. And now we can edit it here in the inspector. It's called iron ingot. And let's say that we need to have 3 iron ore to create 2 iron ingots. So let's drag in our iron ore item here into the inspector. And we need 3 of those, so we just create 2 more entries here. And then we can just drag down the iron ore into these 2 new slots. And for the result, we create 2 slots because we want to have 2 iron ingots. And now we can just drag in the iron ingot here. And again, we drag it down like we did for our iron ore. And this is easy, we have created a new recipe. Let's add another one to create a pickaxe. We can duplicate this one and change its name to pickaxe. And as ingredients, we take 2 iron ingots. And as a result, we want to have a pickaxe. how can we now use these recipes in our game? We can build a simple crafting dialog similar to the inventory dialog that we already built, and then we can craft in this dialog. So let's create a folder for our crafting dialog. We name this crafting dialog. And to save some time, let's use the inventory dialog as a starting point. So we duplicate this inventory dialog scene here, and we name it crafting dialog.tscn. And then we drag this into our crafting dialog folder. Let's first rename the top node here to crafting dialog. Then we can change the title label to something like crafting. And then let's think about how this dialog could look like. I like to draw a little mock-up before I go into making any complex UI. So this is how a crafting dialog could look like. So we have a list of recipes here on the left side, and then the user can select an entry in this list, and this would show the ingredients and the results of the recipe here over on the right side. And then the user can click this craft button down here to craft the recipe. So let's get rid of this grid container and build this. Let's first have a look at the broad strokes here. We have basically two sections, the left section with the list and the right section with our ingredients and results. So let's add an HBox container so we can split things up into a left and a right section. This HBox container should fill the whole vertical size of the dialog. So we set its vertical alignment to expand, and then we can click the fill button, and you can see it expands to fit the whole height of this dialog. Now on the left-hand side, we have a little label on top of our list of recipes. So we're going to need a VBox container, which will stack the label and the recipe list on top of each other. Now we can add the label, and we set its text to recipes. And then we can add an item list, which is going to hold our list of recipes. Let's name this recipe list. And we want this list to fill the remaining vertical space here. So let's set its vertical alignment to expand and then click the fill button. Okay, that looks like we're getting somewhere. Let's add a few dummy items here so we can see how this actually looks when there's something in the list. So we go over here to the inspector, to the items section, and then we can add an item first recipe, and maybe another one, second recipe. Okay, so now we see that the text of our items is cut off, which is not good. It looks like that the item list does not request any minimum size to actually fit its items. So we will have to set a minimum size ourselves. Now we can do this here in the layout settings, and we set the minimum horizontal size to, well, let's say 250 pixels. That looks somewhat okay. And now we can go to the right-hand side. And here in our mockup, we can see that we have another vertical structure. So there's a label, there's a list of icons, and there's another label and another list of icons. So we start with a VBox container. And we want this VBox container to fill the remaining horizontal size of this dialog. So we set its horizontal alignment to expand and then click the fill button. Now let's add two labels. One label for the ingredients and the other one for the results. And finally, we add a grid container for our ingredients. Let's maybe drag in a few item slots from our prepared item slot scene so we can see how this will look. And we see again that we need to increase the columns in our grid container so it renders the items nicely next to each other. Let's also go with 5 here, and yeah, that looks okay. Good, now we can delete our item slots again. And then we can press Ctrl D to duplicate this grid container. And this time we drag it below our results label. So we have the ingredients and results grids, and all that is missing is the crafting button. So let's add a button. and we name it craft button. Now this button currently takes all horizontal space, which is not what we want. So we change its horizontal alignment to shrink end. And that will make it shrink and move it to the right. I also want the button to be at the bottom of our dialog, but because there's currently nothing in our grid containers, the button has moved up here. And we can fix this by adding a spacer control. So Control A to add a new node, and then we select Control. So this is really just an empty control, and we drag this between our second grid and the craft button. And now we can set its vertical layout to expand and press the fill button. And we see that this control will grow to fill any space between our grid container and the crafting button. And this way it pushes the crafting button down. This still doesn't look super nice, but I think at this point it is workable. So let's cut it here and get to the implementation. As a basis, we're going to use the inventory dialog script that we already have. So let's quickly duplicate that. And we name it crafting dialog.gd. And then we can drag it here into our folder for the crafting dialog. And we can also drag it up here on our crafting dialog root node. So then let's first fix up the class name. It's now named crafting dialog. And we need to access the recipe list in our script. So let's make this a scene unique node and control drag it over into our script. We also need these two grid containers for our recipe ingredients and results. So let's first give them a proper name. First one is going to be our ingredients container. And the second one is our results container. And then we can also control drag them into our script. Okay, so now let's have a look at the function that is going to show this dialog. What information do we need here? First, we need a list of recipes for our recipe item list here on the left-hand side. We're also going to need a reference to the inventory, because when the player clicks the craft button, then we want to remove the ingredients from the inventory and put the crafted results back into our inventory. So let's add these two things to our open function as parameters. So first the recipes, and this is an array of recipe. And second, the inventory. Now, when the dialog is opened, we want to add all of the recipes to our recipe list so that the player can select one and craft it. And we first need to clear the recipe list, just like we did in our inventory dialog. So recipe list.clear. And then we can just walk over the recipes that we get as a parameter. And for each item, we add the title of the recipe to our list. Let's also remove this grid container code here, so we keep things nice and clean. And now when the player selects a recipe, we want to fill our ingredients and results containers so the player knows this is what goes into the recipe and this is what comes out. So the recipe list would need to inform us when a user changes the selection. And we can do this with a signal. So let's check the signals of our recipe list. We go to Node. And this item selected signal looks about right. So let's connect this one to our script. And we connect it to a new function called onRecipeListItemSelected. Great. There's a small problem though. This signal only gives us the selected index. But this is not enough because we want to update our ingredients and results containers. And for this, we don't need the index. We need the actual recipe in our hands. So how do we get the selected recipe into this function? Well, the item list has a functionality that allows us to attach additional data to each item in the list. And we can use this to attach our recipe to the list item. So up here, where we add the recipes to the list, we can call a function called setItemMetadata. And in the autocomplete, we can see that this function requires the index of the item to which we want to attach our metadata, in this case, our recipe. So where do we get this index from? Well, lucky for us, the addItem function that we just called above returns the index of the item that we have just added. So we can just save the return value of this function into a variable. And now we can attach our recipe to the item in the list. So setItemMetadata, and we give it the index and the recipe. And down here in our onRecipeListItemSelected function, we can now get the recipe from the list by calling the getItemMetadata function. So recipe list getItemMetadata. We give in the index, and this gives us back the recipe. Okay, now we need to fill the ingredients and results into our grid containers. And this is going to be very similar to how we did this in our inventory dialog. So this is something that we could extract into a separate component and then reuse. Let's save our ingredients container as a new scene. And let's also create a new folder here, item grid. And we put the new scene into this folder. Let's open it up. We rename our root node here to item grid. And then we can attach a script and we name this itemgrid.gd. And all of this goes away. Well, let's also give this a class name so we get nice autocomplete later. So this is going to be an item grid. We already wrote the code for filling items into a grid container. So let's copy that over from our inventory dialog. So we copy this and we paste it over here. And now we just need to do a little bit of fix up. We're going to need the slot scene, and we don't need this grid container variable because this is already attached to a grid container. So we delete this. And now we can change the function here. First, let's rename it to display. And instead of an inventory, it just takes an array of items. And this way we can use it for both our inventory and our recipes. And we don't need this line that shows the dialog because it's just a component. And we also don't need this mouse handling code, so all of this goes away. And now we can just fix up our loops here. So we remove the children from the grid container, and because this is attached to the grid container, we can just remove this grid container variable reference. And here in the second loop, we go over the items that we get as a parameter. And then we can just instantiate the slot scene and add it to our grid container. That would it be for the code. And all that is left is to drag this slot scene into the inspector field. And now we have a nice reusable item grid. So let's first put that into our inventory dialog. So we can delete this grid container node. And then we can drag in our new item grid. Let's make this a scene unique node. And we rename it to grid container, so it matches what we have in our inventory dialog script. Let's also change the type of this variable to item grid, so we get nice autocomplete. And now we can simplify our open function here, right? We don't need these two loops anymore. And we can just call the display method on our new item grid. And we give it the items that are in the inventory. Let's quickly test if our inventory still works. We walk over the pickups and then we press I. And it looks our inventory dialog is still functioning. Great. Now we can continue with the crafting dialog. The ingredients container is already an item grid because we created it from this ingredients containers. but our results container is not. So let's delete this old results container. And then we can drag in our new item grid. We name it back to results container. And we make it a scene unique name. And now we can go back to our function where we fill our ingredients and results containers. And this is really just a one-liner. We can call the display function on our item grid and give it a list of ingredients. And then we can do the same thing for our results container. So now I think it's time we test this out. So let's add this new dialog to our game scene. So we move over to our game scene and then we can switch to 2D mode again so we can see what we're doing. And now we can drag in our crafting dialog. Again, we center it with the center anchor preset. And we hide the dialog so it is invisible by default. Then we can use our UI root script to open up this dialog. We need to have a reference to the crafting dialog in our UI script. So like always, we make it a scene unique node and we can control drag it in here. We also want to open the crafting dialog with the key press. So we need to add a new key to our input mapping. So we go again to project settings, and then to the input map. And here we can add a new input mapping. Well, let's call it crafting. And we bind this to the C key. So back to our script. Here we can check if the player has released the crafting button. And if this is the case, we can open up our crafting dialog. And now we need a list of all recipes. We don't have this list right now, so let's put in an empty array here. And we also need the inventory, which we can grab from the player like we did up here in the inventory dialog. Okay, so how can we get hold of a list of all recipes? There's a simple way that we could use. We can just control drag our recipes up here into our script. And this will create some constants that we can use to fill our array. This is not really scalable because if we have like 100 recipes, we really don't want to have 100 constants in our script here. But for now, we just want to see whether or not our dialog works, so let's roll with that. So we can just fill the two constants here into our array. So iron ingot and pickaxe. And that should do the trick. So let's try it out and start the game. And now we can press the C key and our crafting dialog is actually showing. We have our recipes in the list, which is good. So let's see what happens if we click on a recipe. And yes, the ingredients and results are also nicely updated. Well, let's quickly check out the other recipe. And this seems to work just fine. Fantastic. Now we can implement the actual crafting. So let's go back to the crafting dialog, and to actually craft something, we need to know that the player has pressed this craft button. So let's connect it to a function. So we select the button and then we go to node, signals, and there we have the pressed signal. And we connect this to a new function on craft button pressed. Implementing this crafting function is pretty easy. We can just remove all the ingredients from the inventory, and then we put all the results back into the inventory. We currently don't have access to the inventory in this function, so we need to store it in a variable when the dialog is opened. So let's do that. Now let's first go up here and create a variable for the inventory. And when the dialog is opened, we store the inventory to our new variable. For crafting, we also need to know the currently selected recipe. And we already extract this recipe when the player selects an item in our recipe list. So let's also write this to a variable. So we create another variable up here. for our currently selected recipe, and this is a recipe. And then whenever the player selects a recipe, we just update this variable. And then we can also use this class variable here and here. Now we have access to both our inventory and the currently selected recipe, and we can actually craft something. So let's go back to our crafting function. And now we can walk over our ingredients. So for item in selected recipe ingredients. And then we can just remove each ingredient from the inventory. So inventory, remove item. And for the results, we do a similar thing. We walk over all the results for item in selected recipe results. And then we add each result to the inventory. Inventory add item, item. So let's give this a try and see if it works. We open the crafting dialog, and then we select the recipe for the iron ingot. And then we press craft. And now let's close the crafting dialog and open up the inventory. And we have 2 new iron ingots in here. Fantastic. Now you have probably noticed that there is a bit of a problem here because we just crafted 2 iron ingots out of thin air. It would also be nicer if the first recipe was automatically selected when we opened the crafting dialog. So let's fix these 2 things. Selecting the first recipe in our list is actually pretty easy. So we can call select on our recipe list, and this will select the first item. When we select an item through code, then the item list will unfortunately not send a signal. So we need to call our onRecipe list item selected function so that this function updates our ingredients and results lists. And now for the more interesting problem. We need to check that the player actually has all of the necessary ingredients in the inventory before we allow the craft button to be pressed. So let's add a function to our inventory that can check this. We go to the inventory script and we add a function named hasAll, and this takes an array of items. And it returns a Boolean value that tells us whether or not all the items in the given array are in our inventory. But how can we check this? Well, let's see, we need 3 iron ore, and this is what is in our inventory. Now we can walk over the content of our inventory and we check, is this an item that we need? And if this is the case, we remove this item from the list of items that we need. So we start with an ore, and we need an ore, so we can remove the first ore from the list. The next one is an ingot, and we don't need an ingot, so we skip to the next one, which is a pickaxe. We also don't need a pickaxe, so we can skip to the next item, which is another ore. We need this ore, so we remove it from the list of items that we need, and then we have a sword. We don't need that, so skip to the next item, and there we have another ore. So we remove this ore from the list of items that we need, and we're done. And if we now look at the list of the items that we need, we can see that it's empty. So we know that we have all the items that we need. And if this list were not empty when we're done with our little loop here, well, we know that we don't have all the items that we need. So let's put this into code. The items array that we give into this function is the list of items that we need. Now, when our crafting dialog will later call this function, it will give us the ingredients array directly from our recipe. And it would be really bad if we deleted items from this array, because then we would change the recipe. So let's make a copy of this array and we delete the items from the copy. So we make a new variable, var needed, and this is also an array of items. And we call items.duplicate, and we get a copy of the items array. And now we can walk over our inventory contents. So for available in content. And then we remove the item that we found in our inventory from the array of items that we need. So we call needed.erase available. And the erase function is actually smart about this and will only remove an item if it actually exists. And then we can simply check if the needed array is now empty. Now we have a function that allows us to check if we have all the necessary ingredients. So let's call this in our crafting dialog. So when the player now selects a recipe, we can ask the inventory if it has all the necessary ingredients, and only then we enable our crafting button. We need to have access to the crafting button, so let's make this a scene unique node and control drag this into our script. And then we can disable our button when the inventory does not have all the necessary ingredients. We're also going to have to check this after we have crafted a thing, because then we have used up items in our inventory and we may no longer have enough items to craft this recipe. So let's copy this line into our crafting function as well. Let's give this a try. We open the crafting dialog. And now our first recipe is automatically selected, which is great. And also the craft button is now disabled because we don't have the necessary ingredients. So we need to add a bit of iron ore to our world so we can actually craft something. Well, let's do that. We take this pickup here and we duplicate this. And we change the item to be an iron ore. And then let's create 2 more copies of this pickup. So we have 3 iron ore in total. Now that should do it. Now let's start the game again. And then we can pick up our 3 iron ore. And now let's try to craft something. And we can see that we can now craft an iron ingot because we have all the resources. But if I switch over to the pickaxe recipe, and we can see that we cannot craft it right now because we don't have any iron ingots. So let's then craft the iron ingots. And now our craft button has been disabled because we no longer have the necessary iron ore. But if we switch over to the pickaxe, we can actually craft this because we have converted our iron ores into ingots. So let's craft this one. And then let's have a look into our inventory. And there we can see that all the crafting has actually worked and we are left with a pickaxe. Great. Okay, that worked fantastic, but we still have a little problem left over. Remember when we wrote the code for opening the crafting dialog that we needed to get all the recipes in our game? We postponed this for later, and later is now. So how can we actually get a list of all recipes without having to create a constant for each of them? If we look at our folder structure here, we can see that all our recipes are inside of this recipe folder. So we could load all the resources that are inside of this folder. Unfortunately, Godot does not have a built-in way to load all resources inside a folder, so we need to do this ourselves. Let's first create a variable where we are going to put all the recipes. So var all recipes, and this is an array of recipe, and we initialize this with an empty array. Now we can create a ready function, and to list all files in a folder, we create a loop for file in dir_access get files add. Then we point to res data recipes. So this will look for all files inside of the data recipes folder in our current project. This file variable will contain the name of the file, so we can now combine the folder name and the file name to get the full name of the file. Now we can ask Godot to load the recipe from here. So we say var recipe equals load resource file as recipe. And finally, we add the recipe to our list. So all recipes append recipe. Okay, great. So now we can get rid of these constants. And down here, where we open our crafting dialog, we can use the new array that we have just built. Okay, that wasn't actually so hard. So let's try if this works. So we open up the crafting dialog. And it looks like our recipes are here. Fantastic. We can ship our game now. So let's export our game and see if everything still works after we have exported it. So we go to Project, Export, and I have already installed the Windows export templates. So let's export this to the desktop. And we're going to ignore all of these warnings for now because this is really just a test. And if we now look at our desktop, we can see that we have a new test executable. Well, actually we have two, one that opens up a console and another one that doesn't. So let's use the one with the console so we can see what's going on. So we start the game. And we are already greeted with two errors. Well, that doesn't look good. So it looks like our game is not able to load the resource files which contain our recipes. Well, let's open up our crafting dialog to check this. And indeed, we don't have any recipes in our crafting dialog. Why is this happening? It worked in the editor. Well, when Godot exports our files, then it will do some reorganization and optimization of the file structure. You see here on our desktop, we actually don't have any folders for our exported game. We just have this PCK file, which contains everything neatly packed together. There's a tool called PCK Explorer, and we can use this tool to have a look inside of these packed files. There's a link down in the description if you would like to try it out yourself. So this is the PCK Explorer, and we can open our PCK file by just dragging it in. And well, there seems to be a lot of stuff inside our PCK file. So let's use this filter function up here to find our recipes. So we type recipe in here and press enter. And now we can see all the files that have recipe in their name. So it looks like our resource files, which should end in TRES, have disappeared. And instead we got some .remap files. Well, this is really not great because it totally breaks our loading. We could, of course, do some kind of hack and say, okay, we know that all our resource files are getting renamed to .remap and then account for this when we load them. But this is really a hack because this packing is an implementation detail of how Godot creates an export. And we really don't want to rely on this behavior because it can change at any time and then our game silently breaks. So what can we do then? To solve this problem, I have created a small plugin called Godot Resource Groups. Let's install this plugin and then let's see how it can help. So we go to the asset library and we search for Godot Resource Groups. Click on the link here and then press the download button. We don't need the examples that come with it, so let's click up here. And now we can choose which parts we want. So let's uncheck this examples folder and then click install. Then we need to enable the plugin. So we go to project, project settings, plugins, and here we tick the checkbox to enable it. And finally, after installing a new plugin, it's always a good idea to reload the project. So let's do a project reload current project. Okay, so with the plugin, we can create a new kind of resource, which is called a resource group. Let's add one. So here in our data folder, we right-click, new resource, and then we search for resource group. We want to access all our recipes, so let's name this resource group all recipes.tres. And now we can set up our resource group. First, we need to give it a folder where the resource group will look for resources. We want all our recipes, so let's pick the recipes folder here. Now we need to tell the resource group which files we are interested in. We want to load all the TRES files inside of that recipes folder. So here in includes, we add an element and then type in star.tres. And if we now save the project with Ctrl S, we can see that this paths property here now contains all the paths to all the recipes in our recipes folder. And the plugin will keep this list up to date at all times. So whenever we add, remove, or rename a recipe in this folder, then this resource group will automatically pick it up. Now we can use this in our UI root script to load all the recipes. Let's remove this loop over the file system, which didn't work. And instead, we get our resource group so we can load our recipes. Let's use an export for this because we don't want to hardcode the path. So export var all recipes, and this is a resource group. And now we can select our resource group here in the inspector. Back to our script, here in Ready, we can now call the load all into function of the resource group. And then we give it the list of recipes. And now this function will fill all the recipes from our resource group into our recipes array. And that's pretty much all we have to do. So let's start our game and see if this works. Let's press C to open the crafting dialog. And all our recipes are there. So this works fine. But yeah, we already know we need to export it to see if it really works. So let's export the game again. So project export. And then we export our project. Okay, so let's now go to the desktop and start our exported game. We again use the console version. And there are no errors in the console, which is promising. So let's press C to open the crafting dialog. And all our recipes are there. Fantastic. Over time, your game will evolve and you may need to add or change data in your resources. For example, let's assume we want to add a feature that allows the player to buy and sell items from a merchant in-game. For this, we would need to have a price for each item. We're not going to implement the merchant because this video is already quite long, but let's add a price so we can see how this affects the data that we already have in our project. So let's open up our item script, and here we add a new export for the price. And this is going to be of type int because we charge in coins and there can only be full coins. And we give this variable a default value. This is going to be the value that all the existing items will get. So if we now save this and then maybe open up our pickaxe item, we can see that this has now a price of 5. So adding new fields seems to be quite easy. And because we have a default value, we know that all the items at least have some price set. But let's say we have 100 items and we want to set a custom price for all of these items. Well, then we would need to double-click each item and set a price, and then double-click another one and set a price, and this is kind of not fun. Also, it's really hard to get an overview on what the prices currently are, which is really essential for balancing your game. It would be really nice if we could edit this in some kind of spreadsheet. So I had a look around and I found that a person made a plugin that allows us to edit resources in some kind of spreadsheet. So let's install this plugin and then let's see how this can help us to edit our item prices. We go to the asset library again, and then we search for resources, which will bring up this plugin called Edit Resources as Table 2. So we click the link and we press download. And this plugin also comes with some example data, which we don't want to use right now. So we again click up here, and then in the tree, we deselect this example folder. Now we can install the plugin, and then we need to enable it. So we go to Project, Project Settings, Plugins, and we enable the plugin here. Just like with the other plugin, it's a good idea to reload the project before we use the plugin. So Project, Reload Current Project. And now we have an additional tab up here, which is called Resource Tables. And in this tab, we can edit our resources in a table view. And the first thing we need to do is to tell the plugin which resources we want to edit. We want to edit our items, so we open our Data Items folder. And now the plugin collects all the resources in our items folder and is showing them in this nice table. This is great because now we have a good overview on what items we have in our project and what their prices are. We can sort them by clicking on the table headers. So we could sort them by price or by name or any other information. And the really cool thing is that we can actually edit this. So say we want to set the prices for the iron ingot and the iron ore to 7 coins. Well, I can just select these two, and here over in the inspector, I can type a 7 into the price field, press enter, and boom, we have edited 2 resources at the same time. The plugin also has a filtering functionality. So let's say we want to find all the items that cost less than 7 coins. Well, then we can click here on the Filter Process tab, and this brings up the filtering functionality. And here on the left-hand side, we can type a filter expression, and this can be just any GD script expression. And inside of this expression, we can use the name res to identify the resource. So let's type res.price is less than 7. And if we press enter, we now only see the resources that have a price below 7 coins. So with this plugin, we get a lot of control over all of our game data, and this really helps maintaining a larger database, and we can do this all directly in Godot. In this video, we explored how data models can help us to make our game more extensible and manageable. We started with a very simple items database that was just a dictionary, and then we switched over to resources to represent the items and crafting recipes in our game. We learned that resources have quite a few advantages over our previous approach. We can edit them nicely in the Godot inspector, so there's no syntax to follow. We can easily load them with the build and load function, and they can directly refer to other resources like scenes or other items, and Godot will keep these references up to date, which eliminates any chance for typos and also allows us to reorganize our project without breaking things. We then have built a simple inventory and crafting system to see our data model in action, and we learned how we can use our data model to represent the same item in a 3D world, our game's user interface, and the game's systems like the inventory or the crafting system. Finally, we had a look at how we can dynamically load our resources in a way that works both in the editor and the exported game. And we had a look at a plugin that allows us to manage a large database of items so we can easily tweak and balance our game according to player feedback. Inventory items and crafting recipes are only 2 of the things you can represent with a data model. The same approach can also be used to model a lot of other things. For example, cards in a card game, quests and quest rewards in an RPG, dialogues, unit types in any kind of strategy or shooter game, weapon types, and a lot more. I hope this video has been helpful and maybe has given you an idea on how data models could work for your game. If you have any questions or want to share your approach of working with data in your game, please post them in the comments. If you like this video, please give it a thumbs up and maybe consider subscribing to the channel so you get notified when new videos are posted. Thank you very much, and happy Godotneering!